So now we'll be solving question number 22 from phase 1, chapter called Forces and the Laws of Motion. Let's read the question. The force on a particle of mass 10 gram is 10 I cap plus 5 j cap Newton. So mass is 10 gram, so 10 into 10 to the power minus c kg. And the force is given in terms of I cap j cap, so that is 10 I cap plus 5 j cap. So from here, let's calculate the acceleration of the particle because of this force. So second law, Newton's second law if I use, so F is equals to m into a. So 10 I cap plus 5 j cap will be equals to 10 to the power minus 2. This whole thing will become 10 to the power minus 2 times of a. So acceleration comes out to be 1000 I cap plus 500 j cap meter per second is. This is the acceleration of the particle. Now, if the particle starts from rest, initial velocity of the particle is given as 0. So what would be its position at time t is equals to 5 seconds? So we have to calculate the position after 5 seconds. Okay. So as you can see, the acceleration is constant. Since acceleration is constant, we can use kinematical equations, which are delta S is equals to ut plus half a t square. This equation. So displacement becomes u is 0 plus half into a, which is 1000 I cap plus 500 j cap into t square. Time is given as 5 seconds. So we'll have 5 square, which is 25. It will be coming as 500 into 25 I cap plus 250 into 25 j cap. So 125 equals 0 I cap. So 12,500 I cap plus 650, 6,500. No, I think 25 j cap. If initially particle was at the origin, then the position vector, final position vector, this is basically final position vector minus initial position vector. And if initial position vector I'm taking it as origin, then final position vector minus 0. Coming out to be 12,500 I cap plus 6250 j cap meters. So final coordinate of the particle will be this and this much along the x-axis, this much along the y-axis. Okay. The key aspect of this equation was that acceleration is coming out to be constant. So we have to use this equation to locate the final position of the particle. Okay. Thank you.